Hey guys, it's Mr. Odell. So we're gonna start talk about fossils a little bit more in depth today. Gonna try to make this video quick, and this is gonna get uploaded to Schoology just like normal. So we're also gonna have a Teams meeting today, which our Teams meeting is going to basically just be a touch base, see where you're at, see if you have any questions for me, and then you'll be free to go. So with that being said, let's jump right into it. So we're looking at fossil remains. So as a starter, so we previously discussed using fossils for something. What have we previously discussed using fossils for, and how do you think fossils are formed? So I want you to pause the video, take about, I don't know, a minute and a half, answer both questions. If you have no idea on number 2, it's not a big deal. This is what we're going to talk about today. You should have a rough idea of number 1 at the very least. If you don't, make sure you revisit the past couple of lessons. So pause the video now. Okay, so at this point you should have answered the first question and come up with a theory for the second question. So we're looking at our starter. So we previously talked about fossils and how they're used to identify the age of rock layers. We also I've talked about this idea of an index fossil, which is a fossil that's really, really abundant in that rock layer, and we find it all over the place geographically. So, starting off, we have this idea of an index fossil, which index fossils are essentially fossils that are easily recognized, abundant, and widely distributed geographically. Historically, the really obvious ones that we think of whenever we think of index fossils: trilobites, ammonites, and there's others, but those are the two really big ones that I think of whenever I hear index fossil. So, fossil is essentially preserved remains or traces of once living organisms, and this can come in a number of different forms. Fossils support Darwin's theory of evolution, which evolution is essentially a change in the species over time, because our fossil records show that groups of closely related organisms, and it also shows changes in those organisms over time in the fossil records or in the geologic time records. So, fossil formation. So, our animal, plant, whatever dies. So, essentially, the soft parts of that plant or animal begin to rot, and we sometimes see scavengers coming to eat them. They become decomposed. Excuse me. So anyways, so we now have a skeleton if it's an animal. So that skeleton, or the body, is going to get buried by sediment. So typically mud, sand, silt. There are occasionally, you can see other things like ice, and so those aren't all of them, but those are the majority of them. So anyways, so we see this sediment build up in layers, because we know that our rock layer forms in layers. So as that sediment builds up, it's going to put pressure and weight on the layers below. By doing that, you're eventually going to squash these layers down with enough pressure that they end up forming a rock. So for that rock, a number of things can happen. A lot of times though, we're going to see groundwater seep into that animal part, and it's going to turn that to stone, leaving behind minerals, and essentially replacing the original mineral that was in those bones. So we have a couple different types of fossils that we have to talk to. One is called original preservation. Whenever you think of like something being trapped in amber, that'd be an example. That'd be an example of original preservation. We have this idea of altered hard parts, which includes the categories of mineral replacement and recrystallization. We have molds and casts, and then we have trace fossils. So original preservation, organisms have been altered very little up to not altered at all. Typically requires freezing, an arid environment, or an anoxic environment. Anoxic meaning an environment without oxygen. So this leads to our tissues having that soft tissue preserved. So these are really, really important at times. Great example. We we found woolly mammoths in the Arctic that have basically been frozen as a fossil. Also, you have the obvious insects trapped in amber type of thing from a tree. So altered hard part fossils. So our first one is going to be mineral replacement. So pore spaces of organisms buried hard parts are going to get filled with minerals from groundwater, leaving behind stone material. So this is the one that we described when we talked about fossil formation. Our second one is going to be called recrystallization. So instead of minerals coming in and replacing the minerals, what's going to happen is the mineral already there is going to dissolve and then reform into a new crystalline shape. So I might have a mineral, or might have a shell or something that's calcium carbonate. So whenever it recrystallizes, it's still going to be that CaCO3, but it's going to be in a different crystalline structure. So molds and casts. This one's probably the most self-explanatory to you. So you have a mold, you build a cast out of it. So mold forms when sediment covers a hard part of an organism. That hard part is later removed via erosion, weathering, whatever. So it leaves you with a hollow impression. That impression can later be filled with the material and create a cast of the mold. And then our last little bit, we have what's called a trace fossil, which is essentially indirect evidence of an organism. So this could be anything that tells us information about how the organism lived, moved, and or attained food. So if you guys have any questions on that, let me know. I apologize about the yawns. Make sure you take the notes today and bring questions about this stuff. We're going to try to look at potentially doing a lab of cast and mold tomorrow, assuming I can find the materials today. So hopefully I see you guys tomorrow. If not, then we'll have another YouTube video to go along with whatever content we're looking at.